Transistors are active semiconducting devices used for various applications like amplifier, transistor as switch and oscillator. They are also used for implementing various logic circuits. In design of a transistor, a small semiconducting chip is doped with impurities to form two junctions. Here, this side is N-type doped, the middle section is P-type doped, and the third section is again N-type doped. They can be also doped as PNP. The first side, which here is N-type doped, has excess of free electrons and it is also heavily doped. This side is named emitter. The middle section is very mildly doped and also is very thin of order of micrometer, and the third side is moderately doped and named collector. The middle region is appropriately named base. As we can see here in the electrical circuit diagram, the emitter and collector are on the two sides and base is in the middle, and there is an arrow to distinguish the emitter from collector. This arrow is in the direction P to N, hence we can also distinguish a NPN transistor from PNP because arrow points in the direction from P to N. At the two junctions, like in PN junction, a depletion region is formed due to diffusion of free electrons and diffusion of holes to the respective sides. So, at the emitter junction, whereas at the collector junction, depletion region is formed. Due to diffusion, the barrier potential is set, making this side positively charged due to diffusion of hole to this side, and free electrons diffusion makes this side negatively charged from both the sides. Also, the width of depletion region is more in the base region because it was mildly doped, whereas it is very narrow in emitter side and moderate in collector side. So the base, which was very thin in design and has wide depletion region, becomes poor conducting because it is almost depletion region. Now, to make this transistor work, cell is connected from emitter side to base side, and usually it is kept forward biased, whereas the collector is kept highly reverse biased. This is one of the modes in which transistor can be worked. There are other modes too. Here it is called active mode. The base emitter is kept forward in active mode and base collector is kept reverse. Now, as the base emitter is kept forward, so free electrons will move from emitter side to base side, but since base is a poor conductor, hence it will find no holes to combine with it or very few holes to combine with it. Therefore, the base current will remain poor, whereas these free electrons will easily cross to collector side. Now that the collector is reverse biased, so it will further pull these free electrons, and majority of the free electrons which emitter sends ends up in the collector side. The direction of conventional current, which is in the direction of flow of holes or positive charge, is this: emitter current, base current and collector current. So as the base was poor conductor, so base current will remain very small, whereas collector current and emitter current are large. The emitter current is sum of base current and collector current. In active mode, the base current remains very small and collector current remains large, and any change in base current will lead to large change in collector current, and this active mode is used as amplifier. Thank you.